Hello and welcome to today's video on pedestrian flow, looking into the subway entrance simulation using Anylogic. In the previous video where we look into the concept of simulations and the different types of simulation and some of the popular softwares we use in simulation, I was able to make mention of Anylogic as one of those softwares we use in simulation alongside Sumo, alongside with Vsim and other popular softwares we use for simulation. And in other previous videos we've done, we've been able to look into Sumo, the concept of Sumo, and also some examples and some simulation works using Sumo. But today we are going to be looking into Anylogic and the the most especially some of the terminologies, the terms that are used in the Anylogic um, framework. Then from there, we'll be able to take a look at some examples, maybe some constructions using any logic for a pedestrian flow. So, but before we go into the terminologies, what exactly do we? Why is any logic different from every other software? We know that any logic is a versatile simulation software, and this enables its users to model and simulate complex systems using multiple methodologies, including maybe discrete events, agent based. I think that is one of the things that makes it different from the lives of Sumo and Basin because it's agent based in nature and system dynamics. And it is widely used by business, but it is usually used in businesses and academic institutions for applications, not only in logistics, but also in manufacturing, healthcare, and some other aspects. And one thing about any logic is that it can easily be integrated with AI capabilities and allowing users to train AI agents and incorporate machine learning models into the simulation. So any logic has a little bit of difference. The distinct difference, the difference between any logic and some of these other simulation softwares is that any logic is agent based in nature. So so one of the things that we really need to understand about any logic is first in looking into the subway entrance, that is the pedestrian flow. If we are going to be running a simulation using any logic on this, so we just want to have an introduction into the concept. And the first thing we have to take into consideration is what we call the pedestrian flow. And we know it is the movement of people on foot within a given space. It might be by the sidewalk, it might be on the street, it might be at the corridor, it might be at the plaza, it might be even in the train station, it might be any area where pedestrians can walk freely. Then that area is usually regarded, or probably that the movement around that place is called the pedestrian flow. In a road network, we know we have the vehicle lanes, we have the bike lanes, and we have the pedestrian lane. So movement along that pedestrian lane is what we call the pedestrian flow also. But for the sake of today's video, and we're going to be focusing on the subway, then it's going to be movement within the subway space. It may be coming in how or going out of the train station or the service area within the subway. So it's just the movement of people on foot. So we are not taking a look at those maybe using their vehicles or using bicycles or so, because we're dealing with pedestrians and it's only talking about the movement by foot. So now the ability to now study and analyze how pedestrians move or how they navigate through all the spaces, whether the sidewalk or the corridors or the plaza or the subway, and how they also interact with each other and respond to various environmental factors. This is what we now call the pedestrian flow analysis. So we have the pedestrian flow, which refers to their movement, but now we're studying and analyzing it is what we regard as the pedestrian flow analysis. So, which is very important in what we are going to be looking into. So now, when we go further into the analysis itself, and we know that this analysis it helps us and it is quite crucial when we're dealing with urban planning or any form of transportation design, or when we want to manage the crowd, which is called the crowd management, or event planning. When you're planning towards an event, then this pedestrian flow analysis is very important. And also when we want to build designs or create space that are safe or accessible and efficient for pedestrians to navigate, that is when pedestrian flow analysis is very important. If let's just take it a little bit, let's take it down a little bit. When you want to organize a sporting event in every city or in a particular stadium, you can see that there is a need for people to come together or a group of planners to look into the movement of the people, the movement of the spectators or the audience within the time frame of the football match. Because if the pedestrian flow or the movement is not well planned, then it will become rowdy, it will become a chaos. So but when there is a proper planning in place for the movement of people who are coming to watch that football match or to attend any of that event, then we'll know that everything goes smoothly. So the same thing also happens when it comes to the pedestrian flow analysis too, because all these things, most especially, helps us to be able to manage the crowd. There will always be crowd one way or the other. So the ability to manage it is not just, it's beyond just let's see how it goes, but putting those plans in place for for that flow, and in order to make it what efficient and accessible and safe for all that are involved. So we are going to be looking into some of the terms used in pedestrian flow based on Anylogic, and because everything we're still talking about so far is basically on Anylogic, and we're going to be looking at some of the terms that are used when it comes to the pedestrian flow in Anylogic. So the first terms that we use in this model is what we call the platform capacity. From the word itself, it's talking about the capacity of a platform. So the platform is usually more like the subway, or yeah, the subway platform, when the area, that is the maximum number of passengers that a subway platform can safely accommodate at a given time. So at different given times, we know there are some there are some periods that are off peak periods, and there are some peak periods in a subway. That is the peak period that we have a lot of people going to a particular destination at the same time, and we know how well the capacity or the space or the subway space can be filled up, or the subway station can be filled up to a certain extent. So it is very important to know the platform's capacity, then be able to plan towards having a certain number of passengers within that capacity, within that platform at certain times, in a way whereby it will not exceed the required number or the maximum number within that capacity. So one thing we need to take into consideration is that platform capacity is not like the maximum number of passengers that a subway platform can safely accommodate at a given time. It cannot go beyond that. The moment it goes beyond the capacity, then we know that it's going to become less safe, and it will not be as efficient as the required number or the maximum number that the platform can adequately contain at that particular time. The next point is the passenger throughput. Now, when we're talking about this, it's more like the number of passengers that can be processed through a subway station or a system at a given time. Now, in a subway station, we know that there are some places whereby they are for ticketing. There are some places whereby they tend to process the passengers before they move into the train, or maybe probably what the high speed rail, whatever it is. Now there are different points within that station. There are different points within that platform that processes all these passengers for different motives, different reasons. Whether a point where you have to buy your ticket, another point where you have to pay, or another point where you have to process your luggages, whatever it is. In this point, it is very important that there is a certain number. So this throughput is just talking about the number of passengers that can be accessible, that can be processed through a subway at a given time. There are sometimes, let's just say that if it's during peak period, you see some of them increasing their passengers throughput, that is increasing the numbers. If they have maybe two or three processing points, they might increase it to four processing points as a result of the the numbers of the numbers that is available, or the number of passengers at the subway at that time. And when we notice that it is the off-peak season, you can see some of those stations or these platforms, they tend to reduce maybe to 2 units or 3 units or whatsoever unit it is. So the number of passengers that can be processed as at that time at a given period is what we call the passengers throughput. That is some of the terminologies. The next terminology we have here is the entrance. When we're talking about the entrance, from the word itself, we know what it means, the entrance. So for any way into a subway or into any facility or any area or any building, there is usually a point of entry. So the point of entry is what we call the entrance. And when you have access to a specific area or a facility, it might be a building, it might be a public space, it might be a transit station. But since we're focusing on subway, it might be entrance into the subway, because when you're entering into a subway, you just don't enter into the place and you find yourself inside a train or inside wherever you're going. But there's going to be a building where you are being processed before you get to the train point where you go into the train. But looking into what we are looking at, we're talking about here, we're talking about the entrance into the building where you are going to be processed before you go into the train. So that entrance point, that entry point is what we're talking about. So this is where pedestrians enter a space from the outside environment and begin their This makes the concept of entrance very important. Like I said, it's just the from the outside. So the moment you enter from the outside environment into that space, so that movement, the place of movement, is what we call the entrance. So the next point we are going to be looking into is the subway entrance, or now, this all is it contains a lot of things, a lot of facilities, a lot of activities. So typically we can have the ticketing booth or the fare control areas within the subway entrance, or we can see from the picture here, after the entrance at the beginning point of this diagram, we can see subway and the entrance hall. So there is a lot of activities that takes place in the subway entrance hall, and there are a lot of facilities, and there are a lot of areas within that point. Here we have, like I said, the ticketing booth or the ticketing space. We also have the fare control areas. We have the turnstile. We have the information display areas. In this display point is where you see passengers trying to check the time at which their trains will be leaving. So let's say, for example, a passenger gets to the train station around 4 p.m., but the train leaves around 4:30. So there is a place that displays this information of the name, the number of the train, the train number, the time that it will be leaving, where it's leaving, and the destination they are going to. So from there, passengers can be able to check the time, the number, their train number, and the point of entry or exit into the train. So all these activities or all these things are within the subway entrance hall. And we also have some other amenities also within. Maybe that is where you can have the toilet, which might not really be much important in this video, but I'm just trying to explain that it is beyond just the ticketing booth. You also have the waiting area. This is where the passengers also sit to wait for their trains, especially when they arrive at the train station a bit early, so they have to wait. So these are all some of the facilities and some of the activities that takes place in the subway entrance hall. So, and this facilitates the transition from the street to the subway system. So where you have the movement, so it is from the subway entrance hall, then you now migrate to where the train system is. The next point we are going to be looking into is what we call the pedestrian library palette. And this can be seen in the outlook of Anylogic. When we enter the main page of Anylogic, we can see what it looks like here. So basically, this interface contains some of the models or some of the tools we use in for simulation. So it is dedicated to simulate pedestrian flows in physical environment, and it allows creating models of pedestrian buildings. Maybe when we want to create a subway station, security checks, or streets, maybe with a certain number of pedestrians. So here is we use some of these tools in achieving that. We can see the wall, the rectangular wall. If you want a circular wall, the target line. We're still going to be looking into this when we start with the simulation itself. Through this target line, we'll be able to create a point of entry or the point of exit within the subway hall. Then we have the service with line. That is when you're trying to create the service points and some other tools that are here in which we are going to be making use of very soon. So when we are saying the library palette is just a list of tools that are used in the process of simulation or trying to set up the network. So then the next terminology we have is what we call the target line, and we can see from the arrow there telling us what target line is. That is, you can see that is the target line in the pedestrian library or the palette. And what this does, the target line in a pedestrian library palette, it helps is to serve as a reference point or goal for pedestrians to navigate towards. So, and what it does is that it helps to stimulate how pedestrians move through a space and how they interact with obstacles and other pedestrians and how they reach their intended destination. From what I also explained when we were looking into the palette, I think I said something about this. So when we want to create an entry point in a subway or entry point in a subway hall, or when you want to create an entry point within a building. So we use the target line to create the entry point. And if we want to create also an exit point at any point within the framework or within the building or within the facility, the target line is also used in doing that. I think we'll be able to venture more into this or look more into this when we start the simulation itself. So, but this is just to have a first-hand information about what a target line is all about. Then the next point or the next terminology is what we call the pet source. So when we're talking about a pet source, it's just more like a point or an area in the simulation where the pedestrians are generated and entered into the model environment. So there's going to be a point where we generate a source from the word pet source. Maybe it means the pedestrian source, where the source is coming from. So then that point at which the pedestrians are being generated is what we call the ped source. And the pedestrians are typically created at a ped source and then start moving within the simulation. So we will see the movement. So there won't be, after one we've been able to create the entrance, there has to be a ped source after the creation of our entrance where the pedestrians were moving from. And that is what where you can see here. You can see it from the arrow that we have the ped source, and we're still going to be looking at some other terms that will be used in the course of this simulation. So, but just to have an idea of what ped source is, it is just it represents the point or area and the simulation where pedestrians are generated and they enter into the modeled environment. From what we can see here, this is more like the model environment, but we are trying to create the the pet source here. So the next is the pet to go. Like breaking it down itself, it means ped to go, which means pedestrians to go. So if you want to look at it that way, so that is where are the pedestrians going. So it is a command. This ped to go is more like a command or function that is used to direct pedestrians to move towards a maybe a specific location or a target within the simulation. And we can know that it is used to stimulate how pedestrians navigate the environment and reach their intended destination. So that cannot be done without the use of the ped to go. So where are we directing them to? So when we have the ped source where the pedestrians are being generated, then there is a need to have this commanded function that helps to show which destination that the pedestrians are going or where they are heading to. So that is when we use this ped to go function. Then the next one is what we call the the ped service. Now we have been able to look into the ped source, that is passengers coming in. We've been able to look into the ped to go, heading towards a particular location for something. Now is what we call the ped service. This is just a service point or an area in the simulation where pedestrians can perform certain functions or perform certain actions or perform certain tasks. And some of these tasks, well, the popular one within the subway hall is maybe the buying of tickets. Like I already explained, that these are some of the facilities or these are some of the areas within the hall. And also it might also be in getting informations like the information display center where passengers can go to for informations about the timing or the name or the numbers of the trains available. And also it can also be to access maybe any other facilities within the hall. And other facilities within the hall can be maybe the waiting area. It might also be the restroom area. There are other things there within the pet service. So there a certain task is being done within the pet service, and we say pedestrians may also interact with pet service element as part of their movement through the environment. So there is a level of interaction the between passengers within this pet service, and the pet service is not just one thing. It can be different activities, or we can have different pet service within the hall at different times. Like I said, we can have the ticketing point, we can have the resting area, the waiting area. We can also have the information display area. All these places are service points within the model environment. The next point is pet select output. When we are looking into the model simulation of this within this environment, there is this feature that helps us to track and be able to evaluate pedestrian behaviors, maybe their movement patterns and interaction within the simulated environment. And that is where pet select output comes into the picture. It is just a feature maybe that allows users to define specific output parameters or data that maybe can be collected or analyzed for individual pedestrians as they move through the simulation. So, and this is just an overview so far of what it's all about, but we'll be able to explain more when we start with the applications of some of those terms. The next one is the pet sync. Now, when we look at it, it says pet sync. That is, it's a point where it sinks in. There's a movement into the hall, the subway entrance hall, or from the entrance then into the hall. Then after when all the activities are done, from everything we've explained so far, when you're done with every of these activities, there is a need to exit the the hall. So the ped sync represents the point or the area in the simulation where the pedestrians can leave or exit the model environment. When they get to the point of the ped exit, that is when they have completed their journey task within the simulation. So that is whatever task it is that the pedestrians wants to perform, either by buying the ticket or checking, doing using the information display. When all these things are done, when they are now exiting the model or exiting the simulation model or the all, then that is when we introduce the ped sync, which is more like a means of exit out of the model or the environment. So the next time is we're going to be using is also what we call service in line. So this is just simply a service where pedestrians wait in queue lines until the service becomes available to them. So there is always that point or that line where they tend to wait. And you can see from the picture here, there are two service lines here, service in line. We only have two. So if it's a peak period where we have a lot of passengers coming into the subway entrance, or then we can see that there will be a level of congestion here. And that shows that the having two service in line might not be of help in this case. That means there's a need to have more service in line in this situation. But when we know that it is off-peak periods where we don't really have much people or much passengers coming into the subway station, or then maybe we can use two of it. We'll try different scenarios of maybe having two, maybe having four, maybe having eight service in line when we get into the application, and we'll see how they interact within that environment. So we'll try that when we get into the application. So, but that is what service in line is. So, so these are just some of the terminologies and some of the tools we are going to be making use of in Anylogic, most especially when we are trying to set up the subway. All this information, all these tools that I've been able to explain are just focusing on the kind of simulation we want to run, and that is the subway or simulation. So pedestrian subway simulation. So that is what we are trying to do. And these are some of the terminologies in which I have tried to explain in order to make the simulation a bit more easier when we start or when we want to set it up. So through all these informations, we'll have an idea of what we're doing and won't have to go into much explanation when we are using some of this interface or some of these tools in the simulation. So that means I will see you in the next video with a simulation example. Thank you.